Good afternoon, everyone. My name is Tom Simchak. I'm ESA's Director of Research and Programs. Thank you for attending today's StoragePLUS Network webinar on energy storage and wind energy. This webinar is being recorded and will be available on energystorage.org. Questions can be submitted at any time throughout the webinar via the chat box in your browser. Following the webinar, you'll receive a brief survey regarding today's topic and topics for future webinars. Your feedback ensures ESA continues to provide the highest value information to you and your organization. So we hope you can take a moment at the end of the webinar and let us know what you thought and let us know what you'd like to hear about in the future. All meetings and teleconferences of the Energy Storage Association are held in accordance with our antitrust guidelines. We ask that you abide by these guidelines during today's webinar. The full guidelines are available in the members only section of the ESA website. If you're not yet an ESA member and would like more information, you can reach out to my colleague Richie O'Neill. Membership includes free access to webinars like this one and a range of webinars which we put on for our members, which you can access for free, in addition to those like these that are free. So if you have any questions about the benefits of membership or any of that, please get in touch with Richie. We're happy to fill you in about all the membership offers. Before I begin, I'd like to just give you a brief update on upcoming ESA events. Please save the date for the 2019 ESA Storage Exchange. That is October 15th and 16th in Bellevue, Washington. Storage Exchange is an event designed to examine the steps necessary to successfully integrate an energy storage project and evaluate the different ways companies are deploying storage to lower costs, reduce emissions, and establish a more resilient electric grid. We're going to have a call for poster abstracts opening on the 28th. So the announcement for that and instructions on how to submit a proposal are going to go out via email, so keep an eye out for that, and definitely mark this event on your calendars for October. We also have a Pac Webinar schedule coming up, which you can find if you go to energystorage.org, and then down on the sort of lower right, there's a box for events. On May 29th, we'll be looking at how energy storage can make businesses more resilient to ensure continuity of operations while reducing their environmental footprint. We're also planning an upcoming webinar on the impacts of tariffs on the energy storage sector. We're working with our speakers to nail down a date for that, but that'll be a good one. Super timely, so definitely check back on energystorage.org. We'll have that posted and announce our speakers as soon as we have a date set. And we have many more webinars to follow this year, both for members and some available free to non-members like this one. So keep an eye on the events lists, both on the front page of energystorage.org and in the members only section of the website. So this is the third webinar in our StoragePLUS series, following on from earlier ones about StoragePLUS energy efficiency and StoragePLUS natural gas. The StoragePLUS network examines how energy storage can improve other energy resources through a series of webinars and issue briefs highlighting the important issues that bring together experts relevant to comprehensive planning across the sector as we develop modern energy systems. Today we're hearing from experts regarding innovative coupling of energy storage and wind energy. Our speakers in the following discussion during Q&A will consider how energy storage can complement wind generation and use in innovative energy systems. Our speakers today are John Hensley, Vice President for Research and Analysis at AWEA, the American Wind Energy Association, and Christine Gray, who's Head of Hybrid Systems for the Americas at Siemens Gamesa. So after our two speakers' remarks, we'll open up to audience Q&A. You can ask questions by the chat box at any time, and we'll read those out for the presenters when we get to the Q&A session at the end. So thank you for attending today's webinar, and I will turn it over to John. John, all yours.
Wonderful. Thanks, Tom. And I appreciate the opportunity to join the webinar and give a little bit of perspective from the wind community. So as Tom mentioned, my name is John Hensley. I lead the Research and Analysis Department for the American Wind Energy Association. We are the national trade association for the U.S. wind industry, representing roughly 1,000 members in all 50 states and containing about 114,000 jobs across the U.S. economy and represent about 6.5% of U.S. generation. So that's a little bit about our organization and who we are. And of course, as we've continued to see cost decline on storage technology, particularly battery storage technology, and the increasing penetration of renewables, we've spent more and more time focusing on the storage market. And so I want to begin by providing just a bit of brief background on the history of wind and storage pairings. Now, most of my remarks today are going to be focused on paired co-located sites. I think there's an additional question or kind of topic of interesting discussion out there around standalone storage and how standalone storage can complement renewable technologies and the grid at large. And I'll speak to that just a bit towards the end, but most of my comments are going to be focused on a paired co-located system. So to date, the experience with wind plus storage deployments has been relatively limited. You can see there's been roughly 80 megawatts of paired storage at wind facility sites. These are primarily tended to be pilot projects of very small scale. We're talking sometimes sub 1 megawatt systems or right around 1 megawatt systems. For example, out in Utah, there's an Army base that has a single wind turbine that's paired with a 1 megawatt storage battery system, primarily for resiliency and kind of off the grid application. There are, however, a couple of larger scale installations across the country. One is a site down in Texas. It's a Duke Energy project called No Trees that was repowered recently, and they've installed a 36 megawatt storage facility co-located with that site, primarily as a means to mitigate against curtailment risk on that project, but also to provide additional ancillary services to the ERCOT market. Additionally, there's a project up in the Illinois footprint, a 210 megawatt wind farm that's paired with a 32 megawatt storage facility as well. But in general, a very limited number of projects with limited sizing battery storage systems paired alongside them. Now, the pipeline is also relatively small. Right now, we're tracking around 100 megawatts of storage capacity that's in the queue alongside a fairly robust pipeline of wind projects that are making their way. However, there is a potential upside as we consider things like increasing penetration of renewables and the need to mitigate against curtailment risk, or as demand continues to increase for more of a firmed or base load-like product, as well as state mandates and other types of standards that are looking to provide renewable energy at certain points in time, such as clean peak standards, which we'll talk a bit about more. So pipeline's still relatively small, but expected to continue to grow, especially if we see a number of legislative advancements in the near term. So I want to talk just a bit about economics, and I want to use wind and solar as kind of a benchmark for the increasingly low cost of battery packs moving forward. So these four charts, or at least three of them, show the learning rate of wind, solar, and battery packs. This is basically as you continue to deploy technology, how much does the cost come down on a per annum basis. We've seen that since 2010, solar's come down at a 28% rate over that time period, as we've installed over 400 gigawatts around the world. Wind, slightly less, but still a pretty impressive rate of 11% over the time period, as more than 650 gigawatts have gone in the ground. And then you can see battery packs tracking very aggressively as well, with an 18% learning rate, and costs continue to come down. As this translates into a levelized cost, you can see that while battery storage on its own is still has a fairly expensive premium compared to some of the renewable technologies, that downward trajectory is expected to continue. More importantly, as we start to see these paired resources, we're seeing fairly aggressive paired pricing. Kind of the most famous example at this point is some results that Xcel Energy released from an RFP it put out in its public service of Colorado territory, where it saw a median bid price of $21 per megawatt hour for a wind plus storage facility. Now, sort of unclear what the specifics around each of those bids were in terms of the amount of capacity that was paired alongside those wind projects, but it does speak to the increasing competitiveness and interest in moving these types of paired projects forward. Now, one thing I will mention as we think about the economics of these projects, and that's the current tax situation. So to just give a little bit of brief background, there is no official tax incentive for storage technology, at least at the federal level. What we see happen is that there is the investment tax credit available for both wind and solar technologies. And if you pair a site with a storage facility with one of those eligible technologies, and you charge that battery with at least 75% of the charging comes from that eligible resource, then that battery installation is eligible to take some of those ITCs or claim those ITCs. Unfortunately, on the wind side, the economics of a wind project taking an ITC in order to include the battery storage is just not quite economic compared to, in most cases, compared to taking the PTC and using those production tax credits. Solar, on the other hand, doesn't have a production tax credit, and so it's sort of in a more of a competitive advantage to apply those tax credits against solar plus storage projects. So just a little bit of brief background on the tax situation. All right, so as we think about the potential business cases for a wind plus storage facility, I want to go through some of them and talk about some of the pros and cons of each of these different potential business cases. First is cost savings. And this really comes or is available to both new and existing projects. So being co-located at a single facility allows for a significant number of cost overlaps with economies of scale, can help to bring down your costs. Things like software, engineering, procurement, construction work, and the big one really, system interconnection. So for an existing site, you can't really take advantage of some of that software, engineering, EPC cost savings, but you can take advantage of the system interconnection savings. PERC Order 845 definitely paved the way for basically piggybacking a new storage system on an existing wind interconnection. So essentially, you don't have to pay twice for that same interconnection to include the facility, which can result in significant cost savings. And then, of course, for a new project going forward, you can not only take advantage of that system interconnection cost savings, but also savings on the EPC side of the equation. And these interconnection costs, which sort of make up the vast majority of the cost savings, can be significant, especially when we're thinking about interconnection costs that can be upwards of $50 to $80 per kW. So it can certainly make a big dent. Curtailment mitigation is also one of the avenues that we see cited fairly frequently for including a storage facility behind a wind project. Essentially, if you see a large number of negative hours at your wind facility, you can basically use this free energy to charge your storage facility, avoid those negative hours, and then sell that electricity in the market when prices rise above negative pricing floors. Now, of course, in order for this to happen, we need to see fairly significant levels of curtailment in the markets. And what we've really seen over the last couple of years is that while, think back to 2012 through 2015 in markets like ERCOT or parts of MISO, we saw fairly significant curtailment risk in those markets. But as transmission has continued to be developed, that's helped to mitigate some of those curtailment issues. However, we do see increasing penetration of renewables, both wind and solar, which definitely give rise to additional curtailment risk going forward. So there is a future case for curtailment mitigation as a business case for wind and solar. Price arbitrage, also another potential business case. Here, taking advantage of being able to move electricity from those low price hours to the kind of the premium on-peak price hours. However, again, here what we're seeing is that you need fairly significant price differences in these markets in order to make the economics of these paired sites really pencil out. And in certain markets, we do see that. Think of California ISO that has a fairly big gap between its off-peak and on-peak hours. However, that spread is not quite as large in some of the other markets. So we need to see some additional kind of price volatility in some of these markets to really make the case for a price arbitrage opportunity. Nonetheless, things like price shock to natural gas could certainly spark that. Firming wind capacity is also something that we're seeing increasing interest in. We've seen a lot of interest from the C&I customers that are looking for more of a firmed product, especially since they can't take advantage in a lot of cases of kind of the diversity of resources, cost savings that somebody like a utility would be able to take advantage of. However, again, the economics here are really what comes into play. It really depends on how much of that capacity you'd like to firm. And in most cases, we're seeing a very small portion of that capacity being firmed with a storage facility behind it. Nonetheless, another area for continued business case rationale going forward. And then finally, one that we're seeing some increasing interest in, and actually kind of Massachusetts has been the leading market on this, is the development of clean peak standards. So essentially requiring that a certain amount of the electricity generated during peak hours comes from renewables. Given wind's primarily overnight generation profile, there's significant opportunity there to move that overnight generation into the daylight hours during those peak times. However, what we're seeing is that there probably needs to be some additional advancement in the duration of these storage facilities in order to make that work on a bit more of an economic basis. However, those clean peak standards do help to provide the incentives that are necessary to really help drive that market going forward. And I think the Massachusetts example is a poignant one that will be interesting to see how it plays out and what kind of resources it incentivizes in that market. So those were some of the potential business cases. I want to just briefly hit on some of the areas where we might see some of this take place. And WoodMac, I think, has done a nice job of looking through this in their potential wind plus storage roadmap. They put a map very similar to this together. However, they had California highlighted. California is an interesting case given the predominance of solar in that market, and of course the ability to pair the solar and the storage facility on a much more economic basis. I think we'll have to see quite a bit more either price volatility or the paired resources from kind of the larger WEC region that are bidding into the California ISO market to really see kind of more of a business case in that area. However, in Texas, I think curtailment led some of the initial experimentation with wind and storage facilities. We've seen some of that curtailment risk die down. However, as I mentioned, a fairly significant pipeline of wind projects coming to the market in the near term that could spark some additional curtailment risk, which certainly opens the door for additional opportunity to pair a wind facility with a storage facility and mitigate some of that risk and move it into the higher price hours and avoid some of those negative pricing. In the Northeast, I think there's a lot of interest in pairing offshore wind facilities, especially with the presence of capacity markets in that part of the country, to allow those projects to take more advantage of on-peak capacity pricing and the revenues that come with them. And then in the Midwest, there's a case to be made in the Midwest just given the vast volume of wind projects that are currently in that market. I think there would have to be some more development on the markets front to really continue to incentivize some of the paired facilities, but it does represent a market of opportunity going forward. Now, I want to think just for a minute or two about some of the challenges. One, I mentioned this a couple times, and that's the fact that wind really can't take advantage of, at least not in a scaled manner, advantage of the ITC, which certainly puts solar on a more competitive advantage compared to wind. However, I think, as we think about the future, we are supportive of a standalone ITC for storage, which could continue to bring additional benefits, of course, not just for wind and solar, but for other technologies on the system and the grid at large in order to help provide some of the ancillary services, capacity, et cetera, help to mitigate some of the intermittency risk of renewables on the system as well. So certainly an opportunity or a challenge there as we think about trying to get an ITC for standalone storage implemented. Of course, the intermittent nature of wind does provide some problems. Solar has a very predictable resource profile. Wind is less predictable, given that you may have very long sustained hours of generation, or you may have hours when when the wind resource cuts down below the cut-in speed of the wind project and you're not able to store up the storage facility. And so, there's just a little bit more risk there around the actual resource availability. We are becoming smarter about how to price that risk and understand that risk, so, that is definitely being taken into consideration. FERC Order 841 is a little vague on hybrid resources, and I think it'd be nice to get some more clarity about how these types of paired projects can provide additional services or participate in the services market and providing ancillary services, participating in capacity markets, et cetera. So something to think about. Again, here on the single point of interconnection, just some clarity, additional clarity would be valuable here, as well as properly assessing the capacity of a paired facility so that it's recognized correctly for its ability to deliver energy and capacity. Capacity accreditation is another item that we think about. Accreditation is not well established or well defined for hybrid resources, so some additional work needs to be done on this front, and RTOs should really be clear in their rules on how this capacity accreditation will be calculated for these types of hybrid resources, so they're paid for the services that they actually provide and their capabilities. And then again, market participation kind of writ large is going to be important for continued penetration of these systems. AWEA is kind of in favor of a universal participation model where the system really just defines the needs and sets up the market structure on a technology agnostic basis to implement those, which would certainly in this case help promote additional wind plus storage facilities. All right, that's a wrap for me and from my end. Before I do jump off, I do want to mention an event that we have coming up actually just next week. It's Wind Power. Our theme this year is Wind Plus, which certainly has a lot of focus on wind plus other technologies, including storage. We're going to be down in Houston, Texas, next Monday through Thursday. So if you're interested in learning more about the industry, learning more about wind and storage, or are in the area, sign up, come down, talk to us. It'd be great to see you there. And with that, I'll turn it back over to Tom. Thanks.
Great. Thanks so much, John. Really interesting. As a reminder, the audience can submit questions in the chat box, and we'll put your questions to John and Christine at the end. Now to Christine Gray, Head of Hybrid Systems for the Americas at Siemens Gamesa. Christine, the floor is yours.
Thank you, Tom, and thank you, John. I have to say, after listening to that, you pretty much gave the whole presentation. Everything that John spoke about is very relevant. I would tell you Siemens Gamesa as one of two top world turbine suppliers. These are the actual issues that we deal with on a daily basis with our customers. So any and all places that we can get support, including from OEA, is great. And on the OEA note, I'll just say that I'll be there as well. We have both a wind booth, but also a storage booth there. And should you want to speak about any of this in person, myself and the team will be there in Houston next week. So with that, I'll go into what Siemens Gamesa considers hybrid systems. I won't speak about a lot of the challenges that John did. I think he just did a really good job, but it's really important to understand that SGRE is already trying to help our customers with a lot of those as well, and the more that we can get support on it, the better. So I have a lot of slides here. I'm not going to go through all of them, but I am going to speak on the important parts, considering we have about 15 minutes to go through this. For those who don't know, Siemens Gamesa is known for our turbines. We are one of two of the top global turbine manufacturers in the world, but actually Siemens Gamesa has multiple product lines outside of wind. We're also in storage, as you will see quite quickly, but also PV as well. We have about 90 gigawatts installed in the world. This is included of our offshore platform. Over half of that is maintained by us. We have, as you can see, many of our stats, but we're in all of the major markets and a lot of the emerging markets. So if I don't speak about it today, but feel free to ask me about some of our other countries and what we're doing there as well. So let's get to what is a hybrid system. So for us, we define this as any of the renewable generators together, wind plus storage, storage plus PV, or all three combined. That's our ideal. And at the end of this, I'll go through a little bit of our experience and where you can find some of our hybrid systems for SGRE. Please note, today I'm going to speak about our hybrid systems that are on-grid. We do have an offering for off-grid. It's just not very relevant for the US market. There are some other parts of the Americas that this can be relevant for, and I can speak a little bit about that probably in a different forum, but feel free to ask. Just to go through high level some of our experience, I'll show you some particular projects at the end, but we've been doing hybrid systems since 2007. Our first one was in the Galapagos Island, which was with our wind turbines as well as diesel generators. All the way up to our most recent announcement, which is in Australia, which is Bulgana. It's about a 200 megawatt wind site plus 20 megawatts of battery, which is a 30 megawatt hour system. And there are multiple other projects here, but I'll show you in more detail coming up. So what is it that we offer? I'll go through each one of these, but ultimately what you need to know is that we'll provide a turnkey storage system to our customer, and that's typically what they're asking us for. This is typically a lithium-ion based system. NMC or LFP doesn't. It's up to the customer and what they ask us for. We also have integrated with flow batteries, although not completely bankable today, but we are definitely investigating. SGRE does not manufacture batteries, but we do have storage systems ourselves, just not lithium-based. And again, those are things that I can speak to on a separate note, just not in this forum. So our customers ask us for a turnkey storage system. What does that look like? Well, pretty much every piece on this slide we will offer. So first and foremost, any hybrid system today ends up having to be customized. There really isn't a cut and dry, I want a wind and storage system in New York, Massachusetts, Texas. It's really, you have to look at the actual ISO it's in. How are you sizing it for the system there? What is it that you want to achieve and the different applications, so ancillaries, energy, capacity, et cetera. So we will offer a customized solution for what the customer is looking for. Part of this is the feasibility study. So I would tell you, beyond just providing a hardware system to our customer, which I will speak to what that actually looks like in a minute, is really helping our customers understand the business case for their system. So what does this look like? It's coming up with a pro forma financial statement with the customer on that particular RTO, that particular size, and with the generators that are located there to come up with something that actually pencils out and that you get a return on. John spoke about this a bit earlier, but this is still a challenge, although in the long term, as the lithium prices come down, as the RTOs begin to finally respond to some of these work orders, and there's a little bit more stability and more so clarity in these regulations, this will become much easier. But a good amount of our job and our time is spent with our customers to help them get to the right business case. As I mentioned, on and off-grid systems, plug and play is what we would consider them. EPC capabilities, we don't provide EPC in the US, but we have EPC capabilities both in wind and solar in other markets. And we also offer our customers to manage the EPC selection, et cetera. Financing, we are associated with Siemens Financial, so we have a bank at our doorstep to help us finance some of these systems. And the hybrid O&M. So another thing that we find to be something that's really valuable for our customers, and I'll speak about the main system of this slide, but is our O&M capabilities. So in the US alone, we have over 13 gigawatts of wind installed. And for those who are not completely familiar with wind, you have to have a certain amount of techs on site. And those would be our labor that we pull from in order to help efficiently provide O&M to these systems, whether PV and storage or any combination of all three. As many of you already know, storage does not have a ton of maintenance, but there is maintenance there as well as on the PV side. And any way that we can help our customers manage their cost and their efficiency there, we're going to do so. So we think this is one of our advantages to already have a built-in labor force. So what is the main product that we offer, and what is our main differentiator? This is our hybrid plant controller. It's essentially the brain of the system that manages all three generations, solar, battery, and wind. The HPC, as I mentioned, is the controller for the full system. Also within this, as I mentioned, we manufacture wind turbines. Goes without saying, but we also manufacture power electronics, which is important because as you have these three different systems integrated, understanding when things go wrong, when errors happen, because they all do, having one throat to choke, as we say, is the best possible answer for our customers. So you understand what control system is failing, what actual piece of equipment is, like where is the failure, and how do you solve it quickly is really where we come into play, having these three systems integrated with our power electronics and our controller. And finally, part of the last piece of having a turnkey solution is providing the warranties and guarantees. And now this is more suited for the battery system. So SGRE will wrap the warranties and the guarantees for a storage system, being that we've already integrated with some of the large tier one battery suppliers. That's what our full turnkey storage system looks like. So just briefly, I'll talk about the solar pairing that we have. It looks very similar to the battery storage pairing. I'm not going to spend time going through our turbines. I assume most are more interested in the battery plus as a part of this discussion. So, but I'm also obviously can speak about our turbines as well. But in our solar offering, you have the DC, AC, and controls. So DC system being the panels. Today, SGRE does not manufacture panels, but we can integrate, purchase, rack any of the large panel manufacturers. This is coupled with our AC system, which is our proprietary inverter system, which is within a 20 or 40 foot container, about a 2.5, and now we just released our 3.7 MVA inverter, all UL certified 1500, within a containerized solution with the switchgear and transformer. And then finally the HPC, which is integrated for a solar plus. So solar plus wind, solar plus battery, etc. Because I'd like to get more into what our actual projects look like, I'm going to move on to what our StoragePLUS system looks like. So what we call this product is Restore. It's a renewable storage essentially. So we would take any of the Tier 1 OEMs for batteries and integrate them at site for our customers, whether it's, and I should say this because we are talking about hybrids here, but we do offer this for standalone storage as well. It is just our philosophy that a more efficient generation is more than one generator. So we typically would still be educating our customers that a StoragePLUS is better than standalone storage, but there are some applications that standalone storage makes sense. So our Restore product is any of the Tier 1s, as I mentioned, LG, Samsung, either NMC or LFP offerings, all integrated within a container and or a building or a system that you build on site, plus our power electronics, which is our bidirectional inverter, between a 1 and a 2 megawatt size, depends on the DC voltage range. Again, this is a similar architecture to the PV side, being within a 20 or 40-foot container with 2 inverters, transformer, and switchgear. And then finally, our HPC. So I'm going to go back to what a little bit more about our HPC. So our HPC, just to give everyone a bit more information here, as we described it, it's the brain of the system. What is it made up of? It's made up of the BMS, so the battery management system, but also the EMS. And the EMS takes into account all the forecasting data for the wind and PV side, as well as speaks to the market and the market pricing in order to come up with a forecasted generation for all 3 or all 2 hybrid systems for the owner-operator. We already have this HPC deployed, and I'll get to where those systems are in a second. So John spoke about this, but I mentioned in the beginning, we do spend a lot of time educating our customers on what you use a hybrid system for. Ancillary services is one, energy so far as energy arbitrage is another, but it really depends on what the customer, what the RTO will actually pay you for, what pencils out in the business case, and then finally, how do you size that? I really like this graph because it shows you the power versus energy for a storage system. So depending on what your application is and for what RTO, that's how you would size the system. Now, say a customer comes to us and says, we want storage at this site, what's the size that we need, and what are the applicable cycles, et cetera. We would take that data, or we would take that inquiry and size the system appropriately and give you our recommendation. So with a few minutes left, I will just run through very quickly some of our cases and some of our actual projects. So this is La Plana. This is our customer site that we actually can do a bit of customer testing on. It's essentially our test bench as well, but it has our wind generation, PV panels, 2 types of battery, both lithium and flow battery, and diesel generators. It was originally an off-grid plant and is now becoming on-grid. Why is that important? Well, an off-grid system and being able to maintain the balance within that system is actually pretty difficult. And our controller, our hybrid plant controller, is based off of the off-grid needs. And it was essentially developed here within La Plana. What I had mentioned, this is a customer site. We can actually simulate our customer's load profile within this system. This was commissioned back in 2015. India is actually where a lot of our PV and wind hybrid plants are. We had the first ever hybrid plant in India. This is wind and solar. Fairly small site, but our HPC is actually deployed there. And then we had the first commercial site within India. This is a 50 megawatt wind site plus about 30 megawatts of solar, as well as having our controller there. What's important to note is that we had our full EPC here as well. So EPC for both wind and wind and PV. Balgana. So this is our most recent announcement. This is in Australia, close to 200 megawatts of wind with our 3.4 megawatt system, and it is a 20 megawatt battery with 34 megawatt hours. And we also provided the EPC here, so both wind and storage system. So with that, as I think I've run out of time, I will give it back to Tom.
Great. Thanks so much, Christine. Reminder, folks can submit their questions via the chat box, which you should find down the bottom left of your screen. So let's see. Our first question, let's a bit of a quick clarifying one for John from Vish Business 110. What is the difference between firming and smoothing?
Thanks, Tom, for that question. Essentially, I don't think there is much of a difference. In either case, you're looking to remove some of that intermittency or timing of generation to different hours. So if you see most of your generation overnight, you're trying to move, in a lot of cases, that generation to the higher price daylight hours, or just trying to give a more consistent output profile. And so they generally kind of are alluding to the same things.
Great, thanks. Let's see, I think this one is also for you, John, from Kate McKeever. What are the main barriers in the organized markets to co-locating wind plus storage?
Good question. I hit on a few of these. I think continued implementation of FERC Order 841 across the arch is going to be important to ensure that these hybrid resources are able to participate in the various markets and are incentivized properly to do so. So you to be able to participate in the ancillary service markets, participate in the energy markets, participate in the capacity markets. And in some cases, you want there's generally kind of a lack of market structure to incentivize the different services or requirements that are needed, and are looking for, altered market designs that properly incentivize those services and allow the hybrid resources to provide those services. I think ERCOT is probably a good example where we've seen a number of projects that enter that market looking to not only try to mitigate some of the curtailment risk and also think about some of the price arbitrage opportunities, but they're also there to participate in, for instance, the regulation market. And so with clear market rules and participation structures, we can unlock additional hybrid projects going forward.
Thanks. You mentioned earlier that there is some lack of clarity in 841 about how that would apply to hybrid systems like these. Can you expand on that a little maybe? Like what would be needed in terms of more clarity there to make that work better?
Yeah, I think, for the most part, the order considers individual technologies, or at least that's generally how it's framed, and there's not much discussion around how hybrid or co-located projects would qualify. And so there's some ambiguity of can you actually get a single point of interconnection for hybrid technology or hybrid system, or do you actually need to apply for for that facility? Continue to see these systems implemented around there and then sort of learning by doing. But some of these RTOs are further along in that process than others. For instance, CalISO, which has seen a significant amount of solar plus storage, has quite a bit more clarity on that front than some of the other markets do. So a lot of it's some of these markets catching up as well, and how they're actually implementing FERC Order 841 going forward.
Great, thanks so much. Next one for Christine. Matt Zedler is curious about the Redox flow battery at the La Plana site. He asks, how has the experience been with alternate chemistries, and are there any suggestions on viable options?
Sure. So I would tell you not much that so we've had the flow Redox for a bit. I would tell you it's not without its challenges. I probably can't go much farther into depth with it. But the main point of trying this flow battery was essentially to say we need a scalable option, and we do believe that flow batteries can be that. They just need to they need to really tighten up their technology and have more of a bank, the bankability question shouldn't run into play. I would tell you SGRE has been looking at a couple of different other chemistries, trying to identify the right one that is not a lithium-based. So I guess I would say stay tuned more on that at a later date.
Great, thanks. And Christine, Ralph Shizuki asks, is HPC capable of microgrid control when not grid connected?
I would have to check on that. We don't typically, so it does, HPC does work for off-grid, but it doesn't, we are not a microgrid group. Like our company, our utilities are more, or our customers are more utility scale, so we haven't really had a ton of experience in the microgrids, although there are a few projects, one of them being in the Philippines right now, that we are looking at. So I can't give you a good definitive answer, but I can always respond back.
Okay, thanks. Suchitra Subramanian asked Christine, could you elaborate on the hybrid plan at KUDG India and the split between solar PV, wind and storage, and other stakeholders involved?
Okay, great. Yeah, because I was wondering what that is specifically. So that actual project is solar and wind. It does not include storage. And I think that was our first ever hybrid plan. It's not the commercial size, I believe. So I guess you'd have to ask me more in particular what you're looking for to hear about on that.
Okay, so Suchitra, you can expand on that in the Q&A, and we can follow up in just a moment. Let's see. Peter Riggs asks, other than ITCs, what are the main barriers preventing integration of wind and storage at the same rate as solar and storage? Is it legislation-based, or was the solar industry more open to the integration leading to quicker adoption? John, I'll put that one to you.
Okay, thanks. Some of it's sort of a mixed bag. I think there are a number of components that go into that. One is the resource profile of wind versus solar. So think of a solar project. You've got a fairly predictable resource. The sun comes up at 8 in the morning, goes down at 6, and yeah, every once in a while you've got some clouds that come by, or you may get a shadow every once in a while. But for the most part, that's what your resource profile looks like. And so it's much more predictable to then pair that site with a storage facility and move that generation into the hours or take advantage of service offerings that are available in that market. With wind, it's a bit of a different story. You've got times when the wind blows nonstop for days on end, and so you're not able to charge your facility, or you've charged your facility, you've already expended all of the charge, and you charge it up again, or it may not make sense to continue to charge that facility at that time and just deliver the energy directly into the market. Then at other times you've got long periods where the wind's just not blowing, and so you've got an idle wind project as well as an idle storage facility. So that's certainly one of the main reasons that we haven't seen further adoption of wind and storage systems. The other thing, I think we increasingly think about the value of storage on a standalone basis, which can really help to mitigate some of those issues where you can take advantage of the resource profile across a much larger geography. And so you can really capture that wind resource in those low negative price or just low priced hours and move it, across the grid into those higher priced hours, which is more economic. But of course, we'll need to continue to see the costs come down or have the ITC applied to storage to see that move at scale. But we're getting close, especially when you think of the cost of a new natural gas peaker compared to where some of the storage costs are coming in at today. They're starting to kind of move into that moment of grid parity. So I think a lot more interesting developments to come on the standalone storage front in the future.
Great, thanks so much. Let's see. Jennifer Burke asks, let's see, you mentioned the need for longer duration energy storage. Could you expand on that, and how would you define long duration?
Good question. So it's a question of both long duration, also the sizing to the individual project. So, again, it comes back to what are we trying to do with these systems. In a lot of cases, as you think about the price arbitrage opportunity or mitigating curtailment risk, often you need to move that energy across large expanses of time. And that's not even to mention the seasonality aspect as well, where we see, a lot of generation in the winter and spring months and less so during the summertime. And so, kind of 4-hour duration battery is the gold standard at the point. But does that help you to move 2 a.m. generation to 11 o'clock the next day? Not quite. Additionally, right-sizing these facilities becomes difficult as well. I think WoodMac has done quite a bit of work on this front, and they found that really to provide kind of the on-peak firming that you'd like to see from a facility, you'd have, in some cases, have a battery storage facility that's larger than the actual wind facility itself, which starts to become a pretty expensive project at that point. So, we need to continue to see the technology evolve, continue to see the market rules change as well to see this market really get off the ground in a big way.
Great, thanks so much. Now, Vish Viswanathan asks John, since wind is less predictable, would that not make storage more attractive as a hybrid solution than wind? Do we need longer duration storage to make this hybrid viable?
Good question. It's one of those things where if you were to think about the value across a large portfolio, then storage starts to become a much stronger business case. So as mentioned before, this is where kind of the idea of standalone storage comes into place, where you've got some amount of standalone storage capacity on the system, and you can help to mitigate the intermittency risk across a full portfolio of wind projects. So you can take advantage of those wind facilities that are, generating like crazy at a certain point in time, or seeing high curtailment in a specific location, and help mitigate against some of those risks. Whereas when you're thinking about an individual project, you just have less ability to take advantage of the geography and the market operations and those types of things. So it makes it difficult to capture sound economics from some of these systems, at least at this point in time.
Thanks so much. Vish also asks for Christine here. I shall expand out a little bit on Vish's question. Have you looked at, or do your systems, your packages include fire management equipment or any systems like that?
Yeah, it's considered all part of the storage system is the HVAC system. And yes, that's a pretty large system. I think you have a fire extinguisher. I think that's how you described it. It's essentially helping to manage the temperature of the battery. which is super important. And yeah, there are fire mitigation also as a part of the system as far as the DC container or building.
Great, thanks so much. I think that brings us near to the top of the hour. So I'd like to thank everyone for joining us, particularly our speakers. It's a really great, informative conversation. I'm very interested to hear about the technologies and the policy and regulatory issues around this. So thanks so much. Thank you to our participants for joining us. Before we leave you, I'll take the opportunity to mention again the 2019 ESA Storage Exchange, October 15th and 16th in Bellevue, Washington. Hope you all can be there. And again, poster proposals will be opening in just later this month. If you have any questions regarding any upcoming events or webinars or ideas regarding topics to cover later in the year, please email them to us, education@energystorage.org. And with that, thank you again, and hope you all have a great afternoon. Goodbye.